Good afternoon, everyone. So for the past 2 days, we have gone through what is linear regression and what is the use case. So how are we going to use the linear regression and on what basis it is going to benefit us. So we have seen those things. So now today what we can discuss is we'll go what is classification. Okay, so to enter, I will share my screen before that. Okay. So as I told, we are in the phase of supervised learning. So there are regression and classification. So today we'll talk about classification. Before that, I just want to tell you actually what are the types of data. So like they can categorize into many types. So I will tell you one small two types. Okay, so first one is continuous data and second one is of discrete data. So what is continuous and what is discrete? So continuous means if you want to talk it as a if you will talk a salary, okay, so like it is 10,000, 20,000, 30,000. So these are all continuous data. So, okay, so like it is from minus infinity to plus infinity. So these are all continuous data points. And if I go for a categorical data, so like what is categorical data? So that is what discrete data, we call it as a discrete or a categorical data. So categorical data is nothing but it is just digital, like true or false, 0 or 1. So you can categorize the data. For an example, what are the types of mobile phones, like what are the brands like Samsung, Apple. So you can just classify into 5 to 10 types. So that is categorical data. And so you can understand. So what are class, what I'm trying to explain, it's a categorical data. So yes or no, or what are the gender, like male, female. So these are categorical data. Okay, so first what we have analyzed was continuous data. So like yesterday we have predicted, if I'm going to invest this much amount in research and development, I'm going to get this much amount as a profit. So that is a continuous data. So today we are going to deal with the categorical data. So that is what it is called as a classification. So output you are going to predict whether it is yes or no, is going to come or not, whether it is going to benefit me or not, on what. So that is what the difference between the continuous and categorical data. So we'll talk about it. Okay. So here from the linear regression, okay, we are going to derive a logistic regression. So logistic regression is going to deals with that categorical data. So we call it, it's a classification model which produces the output in the binary way. Like I told you, yes or no, zeros and ones. Okay, so that from the linear regression, how are we going to get the categorical data? So we know I have only linear regression. First point, we know we have a data points. So from that we are going to predict a best fit line. So that is a continuous data. From the continuous data, we are predicting the best fit line. So here, on another hand, I have a categorical data. So how I'm going to predict this kind of data, whether he is going to come or not, true or false, he is going to buy or not. So how I'm going to predict these kind of data? So for that purpose, I'm going to apply that into this. Okay, I'm going to convert that categorical data into the continuous format, like from minus infinity to plus infinity, so that I can able to predict the same way how I applied for linear regression, the same I can able to predict it. Okay, so I will show you one general data set. Okay, so this is a data set of another organi, like a bank company. Okay, it's a bank, that XYZ bank. Okay, so this is their user ID and this is the age of that particular person, and it is his salary, and he purchased a card or not, like a credit card company. Just assume that it's a credit card company. He purchased a card. No, he didn't purchase a card, but this guy with age 32 with a salary, he purchased the card. Okay, so we have a data set of that. So what they want to analyze is, okay, so I have a data for the past days. So I have a person data where for the past days who bought credit cards and who they didn't bought a credit card. So today, so what they have to do, they have to increase their sales of a credit card. So they have to target on high customers. Okay, so they have to target on the right customer who is going to buy the card. So if someone they don't want to buy the car, so we can they don't want to waste the time on them. So if they want to increase the sales of the car, they need to talk to the right person and get the data, talk to the right person and get the perfect this thing. So for that purpose, they are going to do a model for that. So how are they going to do that? So that they are going to apply logistic regression to it. Okay, so this is the data, zeros and ones. So this is a discrete data. So yesterday we have seen is like continuous data, like profit in crores, right? So that and all continuous data. This is a discrete categorical data. Okay, so buy or not. So here if I come, so this graph, so yesterday if you seen the graph, it will be like this. I have a data points like here and there. So I'm going to draw a best fit line. That is a linear regression. And logistic regression, what I have only the values from 0 to 1. Okay, so from that values, how I am going to predict? So for every value, they are going to applied in the same linear regression, and they are going to find that. I will explain how it is going to work. First, I will tell you the use case, how they are going to do that step. Then from that, you will be understand how the graph is arriving. Okay, so to enter into that, I'm just want to give you two basic words like probability and odds. So as we all know, what is probability and so odds may be new. Probability everyone knows, right? So what is the probability? How likely the something should happen? Like if I toss a coin, what is the probability that I will get a success rate of head or a success rate of getting tail? So that is what its probability. So of an event happening divided is equal to number of ways it can happen divided by the total number of outcomes. Okay, so 1 divided by the total number of sample space, right? So number of success divided by total number of outcomes. If I toss a coin, so I will get 1 by 2. So what is the possibility of getting head? So it is 1 by 2. What is the possibility of getting tail? It is 1 by 2. So that is what it is. Okay, and odds. So what are odds? So odds are like, it's again one more term in the probability. So it is like the event, what is that? Success divided by the failure. So like probability that the event will occur divided by the probability of event will not occur. So whether that event will occur divided by the possibility of the event will not occur. Okay, so that is what it is. So how they can define is probability of success divided by 1 minus probability of success is failure. So the failure they can define as 1 minus probability of success. Okay, so from here, if you look at that, so we have a data zeros and ones. So I need to convert that data to my discrete data to a continuous data from minus infinity to plus infinity, so that I can able to predict my values very easily with the help of the line, right? So for that purpose, what they are trying to do, first they are getting this is the output. Y is an output, failure is 0 and success is 1. This is the model. This is the data. So for that, first they are applying odds to the data. Okay, if they apply the odds, what is odds? Odds are nothing but P divided by 1 minus P, meaning success divided by 1 minus success. So if they apply odds to it, so 0 divided by 1 minus 0, 0 by 0, right? So 0 by 0 will give me 0. And if they go for the same, what is that? 1 divided by 1 minus 0. So 1 minus 0 is, but 1 second, just 1 minus probability of y. Okay, so 1 divided by 1 minus this thing, so that they will get a infinity. And the same if they apply log of odds. Okay, so log of 0 will give you, what is that? Log of yeah, failure. So log of 0 will give you minus infinity, and log of infinity will be the same, infinity. So they are converting the data from 0 to 1 to minus infinity to plus infinity. So so from this, they are applying the same. We have only one equation, which is y equal to beta naught predicted plus beta 1 predicted, that linear regression. So from that regression, they are from that equation, they are applying the log of odds to that, so that they are getting this particular equation like this. So log of this equation like y, that is a y. So this is the odds, P of y divided by 1 minus P of y, the same equation. Yesterday we have seen the same equation, beta naught plus beta 1. So from this, they are getting the output of like this. So probability of y of success, which is equal to, so when you take this log to this side, it will become an exponential, and it will be like this. So I need a probability y. So I need only y value. So y of x equal to, so log will go to this side, will become exponential. And if you get 1 minus p to that side, it will be like this. Okay. So the same at the end from the linear regression, they arrived at the logistic regression. Okay. Here, what will happen? I told we have discrete data 0 to 1. We are converting that data to continuous. So like minus infinity to plus infinity. Like so, what is continuous? Like it is like 0 0.1, 0 0.23, 0 0.53. So these are all continuous. Data is continuous. It is not like 0 and 1. Okay, 0 and 1s are discrete. So it is a continuous data. So if you convert that, at the end, what will happen? How are they going to predict whether he is going to buy the card or not, or he is going to come or not? So this kind of prediction will happen like this. So my original output is 1, he bought the card, and I'm going to predict him like 0.75. So why I'm getting decimal value? Because we converted into that particular logic link equation. That is what it is, that discrete data got converted into that continuous. Okay, so after you convert it into continuous, if you apply the same one into this equation, it will be like there is something called as maximum likelihood estimation. So that will help us to get the output in the way. Okay, so that is very vast topic. That maximum likelihood estimation is very vast topic. So what it will does is, it will try to find the same what we did for that gradient descent. It will try to find the best fit line. So which line will give us the minimum error, we are going to consider that as a best fit line. The same here, what it will does is, it will go for a maximum likelihood estimation. So it will try to estimate each and every steps, like which is going to give me the best value in the prediction. Like if it is 0, what it is going to be very equal to 0, like 0.01, that is very less equal to 0. So for that, it will take many trials and it will get the output. Okay, so there involves integration also at the inside of maximum likelihood estimation calculation and all. So as the output of that, we are getting, if it is 1, if I am applying into that equation, I am getting a 0.75. That is what my model will predict. Okay, so if it is 0.75, how I can get it to threshold? How I can get it as a discrete value? We need as a discrete value. Even though for our purpose we are converting the discrete into continuous, we need a discrete output, right? So to get the discrete output, what will happen? We are going to set a threshold to it. So what is the threshold? So threshold is like, basically they will set 0.5. So is as per the data what you want, you can set a threshold to that. Okay, so if you set a threshold of 0.5, if whatever values which is greater than 0.5, I'm going to convert that as 1 from the continuous predicted output, and whatever values which is less than 0, I'm going to convert that as less than 0.5, I'm going to convert that as 0, which is false. Okay, so this is how we are converting that. Okay, and to check the model performance and this thing, like yesterday I told you, for a linear regression there were R square and RMSE, and here it is like a confusion matrix, accuracy, precision, ROC curve and all will come into play. So what is a confusion matrix? It's like simple. This is my actual my actual thing is like, I got a card and my model predicted it is actually he got a card. So that is called as true positives, right? So truly that guy bought a card, but actual value is a failure. He done bought a card, but my model predicted it as he bought a card. So that is called as false positives. So this is what confusion matrix. So these are all the metrics they are going to use to estimate the performance of the model. They're going to check the performance of the model. So in this case, if it is an accuracy is like true positives plus true negatives. So how my model predicted as true positives and true negatives are correct. Actually, it is success, and my model predicted it as also success. Like actually, he bought a card. My model also predicted he bought a card. Actually, he didn't bought a card. My model also predicted he didn't buy a card. So these are all correct values. So this is one of the metrics: accuracy equal to true positives plus true negatives divided by true positives plus the total of all, the same precision. So if I want to go only for true positives, so they will go for this particular metric, how my model is getting. And this is at the end, they will go for this curve called as the receiver operating characteristic curve. So This is again a very big this thing why they go for receiver operator characteristic. So at the end, if you want to see, this is the area under curve. So if you get the data points 0 0.5, 0 0.0, so if I try to plot this point, I'd say at the end I will get like this. So if I get the data in the, if I get a point like this, so I'm getting maximum amount of true positives under this. Okay, so at the end, like yesterday I told you, there are different models. Okay, so at the end what they will do, they will calculate, they will do all the models and they calculate which model is giving me less error. They are going to take that model for their better use case. The same way here, classification, they are going to do all the models. Okay, logistic and support vector, decision tree, random forest, they will do all the models, and at the end which model is going to give you the better area under curve, the percentage of area under curve will be high, they are going to use that model. Okay, just 2 minutes, I will just explain you the use case here. Okay, so if this is a data, okay, so the same like this thing, 1 second. Okay, so here the same model. So what I'm getting, so I'm just importing the libraries. The same, I'm taking the training data set here, like yesterday. As I told, the steps in model building training. So you have to do the pre-processing and all, and at the end you are going to do the prediction. So like I told you yesterday. So the same, if you take the, it's a training data set, I'm importing, and here I'm again separating the dependent and the independent variable. What is my independent variable and what is my dependent variable? And here in this data, this is my dependent variable, right? So I need to go this variable purchase card is dependent on these two data sets, right? Age and salary. So these two are independent variables and this is an dependent variable, right? So I'm just taking the data x train and y train, which is dependent, x is an independent and y is independent. So I'm just splitting the data. And again, yesterday I told you like we need to do some pre-processing in the data set y. So here I'm doing one step of pre-processing, which is called as scaling the data. Scaling is nothing but which is a normalization of the data. Why I'm doing? Because here, if you look at the data set, so this is, if I try to plot the graph, the age is like around 19 to 50 years of age. So the graph will be very small, 19 to 50 range. But if I try to plot the same salary in the same graph, it is around 19,000, 20,000, 20. So I cannot able to, so one level of where data points is here and one level of data points is like very high. So I cannot able to plot it in the graph and I cannot able to do the model. So for that purpose, they are going to do normalization. So the normalization, nothing but they will do scaling. So all data is from very like -1 to +1. That's all. So if it is 19, that will be around some like minus plus 1 point 0 point something something something, and the 19,000 it is like around like plus 1 point something something. So it will be like that. Okay, uh, so that is what the scaling is all about. So after doing the scaling, I'm going to do the logistic regression. Yesterday you have seen it is a linear regression. Now it is a logistic regression. So that classification equal to, I'm getting the creating the instance. So after that I'm doing the fit. So fit of X train comma Y train. The same I'm going to do. And at the end I'm going to predict this model. And here accuracy, and this is a confusion matrix step. I told you that what is the confusion matrix, and here what is the precision and what is the area under curve, and I am trying to plot this area under curve. So if I just I will just explain this also. And at the end, there is only one small test data. So this is a test data. So these are all the new users. So they have to target that customers, like whether they are going to purchase the card or not. So they have the same data. So they are going to purchase card or not, they don't know. So we are going to train the model on the training data set. This is our training data set. So we have a purchase card or not. So from this training data set, we are going to find this test data set, right? So that is what we are going to do now. So if I just try to run the model, okay, 1 second. Okay, so this is a area under curve. Like for my model, my true positives and false positives, and my area under curve is around 80%. So whatever from the data, my model going to predict is very high. Like I'm getting more true positives value, so I can able to use this model for my test data prediction. So I'm just closing this. Okay, so I'm getting the confusion matrix and what are my true positives, like 99 true positives and 20 false positives. So these are I'm getting under precision accuracy, and the test set results, like this is a test data. So this user ID with the age of around 20 and salary, he is going to purchase card or not. So this age user ID, like first user ID, he is not going to purchase a card. From my model prediction, he's telling that it is telling that he's not going to purchase a card. And this user ID, like 512, this particular user ID, if I go for 512 with this around, he is going to purchase a card, yes. So you will get output of no or yes. So from that they are going to filter the guys who are going to purchase a card only yes, and they are going to target those audiences. They are going to target those particular customers, and they will get the uh, they are going to talk, and they are going to convince them to purchase a card. So it is like, it is, if it is giving this as a yes, it is like more likely that those guys are going to purchase a card. So from the prediction, so this is how they will use like credit card companies, or even there are many use cases I can take and tell you. So first, this is a major use case, like how credit card companies are going to target the customer who are going to purchase a card. So this is one small use case. So from this, it is over what is logistic regression. And from these 3 days, we have seen what is a supervised learning. So I told you what is supervised. We are going to supervise a model. You have a pre-trained data set. You have a labeled data set. From that labeled data set, you are going to find the model. So you have both the, from two use cases you have seen. From the linear regression, you have a labeled data set. What is my profit already there in the training data set, and in this data set you have the card purchased or not, right? So that is what it is labeled. Okay, so that is what supervised learning is. And regression and classification, I told you what is regression. We are going to deal with continuous data, and classification, we are going to deal with the discrete data. So this is the completion of supervised learning, and I explained linear and logistic regression, and a few more models. We'll see that. Okay, so that is what it is. It's end. Yeah. So any questions so far? Or we can go ahead.